Alright guys, welcome to page 6 of 8. We're almost done. Let's go ahead and start with number 25. So we are multiplying rational expressions. First thing is factor everything that you possibly can. So I'm going to go ahead and I'm going to try and factor. I'm going to do the first one. So we have x and x. Two numbers that multiply to 8 but will add or subtract to 6. So I know that's what? 2 and 4. I need it to become negative but multiply to be positive. So those are both negative. Next one, I'm going to do the bottom. That's x and x. 2 and 6 this time. It's going to be positive 6, negative 2. X plus 6 is already in factored form, so I'm just going to rewrite it. Not rewrite it, just keep it the same. And then we're going to factor the other. That's 2 and 4. This time 4 is negative, 2 is positive. Before we start canceling, we have to find our restrictions. So x can't equal. What numbers will we plug in here will make the denominator 0. So set everything in the denominator equal to 0 and find what it is. So x minus 2 equals 0, we'll get positive 2. X plus 6 set equal to 0, we'll get negative 6. Plus 2 equals 0, we'll get negative 2. X minus 4 set equal to 0, and we'll get positive 4. Alright, so we actually have 4 things that will make the denominator 0. So that's what x can't equal. Now we go ahead and cancel stuff out. We have x minus 2 is here. We have an x minus 4 and an x minus 4 way out there. And we have x plus 6's. So everything on the top canceled out, which means we're left with the number 1 over just an x plus 2. And then those are still our restrictions. There's our final answer. The next one, number 26, same exact steps. Great. Factor what we can. So we have an x plus 3, can't factor that. X minus 5, can't factor that any further. But on the bottom, we have an 8x minus 40. I can't factor it into 2 parentheses, but I know 8 is the biggest number that goes into both 8 and 40. So we can take out their greatest common factor. And when we do that, we're left with x minus 5, because 40 divided by 8 is 5, and 8x divided by 8 is just x. This bottom right fraction, we're just going to go ahead and factor. It's 1 and 3, plus and minus. Like always, we're going to restrict our domain, or just restrict our fraction. The 8 doesn't have an x, so if we set it equal to 0, that technically is 8 equals 0, which is not true, so we ignore it. Anything with an x is what we set equal to 0. So x minus 5, set that equal to 0, we'll get positive 5. X minus 1, set it equal to 0, we'll get positive 1. X plus 3, set it equal to 0, we'll get negative 3. Now if we cancel stuff out, we have a minus 5, plus 3, plus 3. Again, everything canceled out on the top, so we're left with 1. And on the bottom, we have an 8 and an x minus 1. You do not have to FOIL back the 8 in, because then you'll just take out the GCF and it's a giant loop. So you stop there. The next one is a little different. We're adding. So now when you add, you have to have the same denominator. Right now, that doesn't look like it, but I'm actually going to go ahead and factor the bottom, 2x plus 5 and x minus 5, because those are difference of perfect squares. Now if I look here, they both have an x plus 5, but this one has an x minus 5 and this one doesn't. So I'm going to multiply the second fraction by what's missing, which is x minus 5. Now that the denominators match, I only need to write it once. And basically, I ignore all this, and we're going to focus on the top. Step 1, distribute. So the 4 is still there, But now on the top we have plus 3x squared minus 15x. If I rewrote this, that's 3x squared minus 15x plus 4. Alright. We can try and factor it, but I don't think anything's going to cancel out because nothing times 4 will give us a 5. So our final answer is just going to be 3x squared minus 15x plus 4 over x minus 5, x plus 5. And we can stop there. Okay. Find the real zeros on our graphing calculator. Zeros is another word for x-intercept. So if you wanted to, you can put it in the calculator, or you can just put it into Desmos and tap where you find the answer. So that's exactly what we're going to do. I'm going to pull up Desmos. If my phone decides to, let's go ahead and do that together. So to start, I'm going to go ahead and plug in our formula. So that's y equals x. Oops. Yx equals to the 5th plus 3x squared minus 2. Okay, so now that we have that, we have two x-intercepts. Oops. Laptop is about to die, so let me charge it and I'll be right back. Alright, sorry guys, I'm back. Laptop was starting to die. Alright, waiting for it to catch up. Alright, once we used Desmos, you saw that those were the two x-intercepts. Okay, next up, we're simplifying, just like the last one. We factor what we can and cancel stuff out. So here, if we try and factor, let's see, we can try, I don't know, let's try 2x and 2x, and then 1 and 5. That's 10, 9, 8. That really wouldn't work. So let's try 4x and 1x. And let's do 5 here and 1. Alright. Let's try this again. So we're going to do 4x and x, 1 and 5. That becomes 4x squared, 4x, and 5x. So minus 4x plus 5x will give us x. If you are struggling, please, you might have to do the tree method, the upside down Charlie method, or box method, whatever method you need to use. The bottom, I noticed that 16 and 25 are all perfect squares. So if we factor that, that becomes 4x minus 5 and 4x plus 5. Right? Because the square root of 16x squared is 4, square root of 25 is 5. So we have a plus version and a minus version. Now we can go ahead and restrict our domains. X can equal 5/4 or negative 5/4. That's because we set the denominator equal to 0. Then we notice the 4x plus 5's cancel, and we are only left with x minus 1 and 4x minus 5. And there's our final answer. Next one, notice it's a cube root, so we're looking for triplets. If I take 250, I know that's 25 times 10. 25 is 5 times 5, and 10 is 5 times 2. Look at that. We have a triplet of 5, so a 5 can come out. But the 2 did not have the 2 other 2's, so it stays inside. X to the 9th, if you wanted to rewrite it, that's technically 9 divided by 3, because we take the 9 and we divide it by the index. And 9 divided by 3 is perfectly 3. So that comes out completely. Next up, we have y to the 5th power. If we tried the same method as the x, that becomes 5 divided by 3. but that gives us a decimal. So we're going to have some things left over, which means if you want, you can go ahead and rewrite it as 1, 2, 3, 4, 5, because y to the 5th, that means you have 5 y's. So we have one group of 3, so we can take out a y to the 1, but 2 of the y's couldn't come out, so y squared is left inside. So our final answer, if we put it all together, everything on the outside is together and everything on the inside is together. We have 5x to the 3rd and y to the 1st power. Remember, it started as a cube root, we have to end it as a cube root. A 2 and a y squared couldn't come out. So there's our simplified answer. Next up, we have more simplification. Notice how it's a square root because there's no number, it's automatically a 2. Before we go ahead and break things down, I'm going to combine everything. So things on the outside can be combined. So 5 times 3 is 15. And on the inside, we have 3 times 9, which is 27. X times x to the 3rd is x to the 4th power. Y squared times y is y to the 3rd power. So now that we have that, we can go ahead and do the same method we did here, but instead of triplets, it's a square root, so we're looking for pairs. The 27, if I break it down, that's 9 times 3, and 9 is 3 times 3. So we can take out a 3, but that 3 stayed. X to the 4th, if we do the same method, that's technically, let's do it on this side, x to the 4 divided by 2, because if there's no number here, it's automatically a 2. That perfectly becomes x squared. So when x squared comes out, y to the 3rd, that's a decimal, so that's 1, 2, 3 y's. We can take out one group of pairs, but there's a y that stayed. So our final answer, everything on the outside. The 15 is still outside, so we have to do 15 times 3. So let's see, 5, 3, 4, that's what, 45? Yep, so we have a 45 on the outside, we have an x squared, and we have a y. And inside is 3y. Now there wasn't much room for me to show all my work, and I know it was a little messy, but hopefully on your test or on any homeworks that you guys have, you can get it more organized than what I could have clearly. Okay. That wraps up this page. Go ahead, try the next one. If you struggle on anything, go ahead and see a teacher, look up other stuff online. There's a bunch of other math videos that you can watch. Okay? See you guys next time.